Welcome to Osoyoos, British Columbia, the south central interior of the province, one of the warmest places in the province, one of the warmest places in all of Canada. And it's a great place to talk about atmospheric radiation. So everything in the universe gives off radiant energy, and it does so based on its temperature. The warmer a body is, the more radiant energy it gives off. The sun's warmer than the earth, so the sun gives off more energy. But the warmer the body is, it also changes the wavelength at which most of the radiation is emitted. And so the sun gives off shorter wavelength radiation, and the earth gives off longer wavelength radiation. So temperature and wavelengths of radiation go inverse with each other. So the earth is giving off radiation today, and it's giving off a lot because it's pretty warm. It's about 30 degrees right here in Osoyoos right now. And that energy could be emitted out into space, except we have an atmosphere. And the atmosphere is made up of all these sort of different gases, and those gases vibrate and rotate at different frequencies, depending just on their basic molecular structure, just basic physics and chemistry, right? And so it works out that the three most common gases in the atmosphere, nitrogen, oxygen, and argon, they don't vibrate or rotate at frequencies that can absorb radiation coming up from the Earth's surface. The next most common gas, carbon dioxide, it does. And so that's why a gas that's not common in the atmosphere, like carbon dioxide, that's found at a pretty small percentage, ends up being really important to the planet's energy budget. Because CO2, just because of its molecular properties, something that was figured out back in the 1800s, is able to absorb radiation at the wavelengths that it's given off by the Earth in its lower atmosphere, which means CO2 is going to be absorbing radiation emitted by the Earth's surface. That also means that CO2, well, those molecules in the atmosphere have a temperature, so they're also giving off radiation. So CO2 in the atmosphere and other greenhouse gases like it absorb radiation. They also emit radiation, and that emitted radiation they emit goes off in all directions, some of it back out to space, but some back down to the surface. And that means that the Earth is absorbing radiation. Radiant energy is coming in both from the sun, but also from the atmosphere, because the atmosphere has this sort of back radiation that's coming back down to the surface because of greenhouse gases. And this greenhouse effect isn't a new thing. It's not specific to the science of climate change. It just emerges from what we know of physics and chemistry. And as I mentioned, it was the basic science of this was developed back in the 1800s.